Lesson 80. Go ahead and do the warm-up. Be sure to pause the video and see how you do and come back and away we'll go. All right, here we go with the answers. This case had a minus sign between them, so you add the opposites. Now they're both negatives. We have negative 30 and negative 45, so they make a negative together, and they just combine 30 plus 45, which is 75. Okay, 40 squared. 4 times 4 is 16, and then because there's going to be two zeros that are multiplied through. Okay, this one in my head I added 4 to both sides, so now I got 5q equals 40. So 5 times 8 equals 40, and that's where we get q. This one's probably the hardest one in this. 15 is 3/5 of something, okay? Well, if 15 is 3/5 of it, we're going to take 15 and divide by 3, okay? So 1/5 is 5, and because 15 divided by 3 makes 1/5, and multiply that by 5, we get 25. Or we could do the chart again. Okay, this time again, kilometers is to the left of meters on that chart, so we go 1, 2, 3, and we end up with 1.5 kilometers. Okay, what is 3/5 of 15? Well, 1/5 of 15 is 3, so 3 times 3 is 9. All right. It's okay. I went through those fast. If you're still struggling on some of those, that's okay. I don't think I would have done well with those when I was in middle school. Just saying. Okay, now we're going to talk about transformation. So I'm going to set this aside for a minute. I'm going to show you two congruent triangles. Okay, I'm going to do one like this and one like this. These are congruent right triangles. Okay, I know this because I cut them out from the same template. Are they both on the screen-ish? Here. Well, no, I actually want them side by side. I might need to back up. All right, so I have two congruent triangles. And that means all their dimensions are equal and they have the same shape and side. These two triangles are congruent, but they are not in the same position, are they? Okay, we can use 3 types of position changes to move triangle 1 to the position of triangle 2. One change of position is to flip triangle 1 this way. Flip it over. Whoops. So I just flipped it. Okay, I did a flip, and as you can tell, once we get the flip, we can do what we call a slide. We can slide it over there. So I flipped, slid it, and then the last thing I need to do is, in order for them to land in the same spot, is, I'm sorry, I didn't do a great job there, is rotate. And now they're in the same position. So just to repeat, this was where the green was, looked like this, right? So we flipped the green over, slid it over, and rotated it, and now they're in the same position. Okay, we did a flip, a slide, and a turn. All right, so now we're going to go back to your paper and show you what those words are. We did a flip, and mathematically we call that a reflection. It's just another vocabulary word. And you guys get that because it's like a mirror. So a flip, the transformation of the flip is the action, it's called a reflection. When we slide, it's called a translation. When we turn, it's called a rotation. And those are all 3 forms of transformations. Okay, and another thing to tell you is when we do transformations, let's go back to this. This was the before and this is the after. So we call this the pre-image and this is the image. The pre-image is what you start with. The image is what you get when you've done all of the transformations. So after we do those transformations, then the pre-image shows up. Okay. And another thing is when we are talking about them, we'll show you. We'll actually talk about this, and the image is going to be have a different notation, and I'll show you what I mean. Let's look at example 1 actually, and here we are. The coordinates of the vertices of triangle RST are, they give us these three coordinates. Angle R, or the vertex R is at 4, 3, S is at 4, 1, and T is at 1, 1. Let's just find those. Okay, R is at 4, 3. So I'm going to go over 4, up 3. And I'm going to label that R. And you're going to do it too, because I gave you paper to do it. And then S is at 4, over 4, up 1. That's S. And T is at 1, 1. So there we go. There's our T. Now what we're going to do is, since it says triangle RST, we're going to use a straight edge. We're not going to freehand this. Or we're going to, I'm going to label my T. Okay. I am drawing our pre-image. Okay. And we've done the first thing. The coordinates of the vertices of RST are right here. Okay. Draw RST, which we just did, and its reflection in the x-axis. Now we've got our triangle R prime, S prime, T prime. This is how we talk about the new image, or the image we have created from the pre-image. So the image has these apostrophes, and that means prime. R prime, S prime, T prime. And we need to find those new coordinates on this reflected in the x-axis. So we're looking for a reflection, meaning if we folded our paper at the x-axis, now remember this is the x-axis, it's the horizon line. If we folded this up or folded this over, this triangle would end up down here, right? The image would be down here, reflected. So it actually would be, we'd have a point here, we'd have a point at 1, -1, and we would have a point at +3, negative. Did I go? Oh no, +4, -3. 1, 2, 3. Okay, I'm going to draw that, and then I'm going to label it with the correct notation. So I just drew our image, our new triangle, with a reflection over the x-axis. Okay, and what used to be S is now S prime, and that's going to be right there. R prime, see how these two were basically partners, and then this would be T prime. Okay, and that's how we do that. What are the coordinates of the vertices of R prime, S prime, T prime? So what we're going to say is this, this, and this, and we're going to write their coordinates. Okay, so R prime was +4, -3. S prime was +4, -1. And T prime was +1, -1. Okay, and it's always neat to see if there's any sort of pattern. I'm going to write just for you R, S, T. Patterns are good to notice now at this age, so that when you get into this, especially in geometry, you'll be like, oh yeah, I remember when you reflect something over the x-axis, this is what happens to their coordinates. Okay, the original coordinates were R, S, and 1, 1. Okay, notice all of their x coordinates stayed the same. What happened to their y coordinates? We had a 3, and now we have a -3. We have 1, we have a -1, and we have 1 and a -1. They change signs. So your y value switches signs, and that's what a reflection over the x-axis is. If you do a reflection over the y-axis, these will stay the same, the y values will stay the same, but the x values will become opposites. So that's kind of exciting to me. Pattern. Okay, example 2 now. The coordinates of the vertices of a rectangle A, B, C, D are those. So we're going to draw it. So I'll go ahead and draw it. In fact, draw this. Draw the pre-image of this. Draw A, B, C, D. And also go to example 3 and draw PQR. And then come back and we will do what it tells you with the transformations. Okay? So go ahead and pause this and draw the two the two pre-images. For example. Okay, so here we have rectangle A, B, C, and D. Okay, so you should have that on your paper. Now we're going to draw its image, A prime, B prime, C prime, D prime, translated to the left 5 units and down 4 units. So that means we take each of these points and move them to the left 5 and down 4. So let's take D for example. If we go to the left 5, it goes 1, 2, 3, 4, 5, and then it goes down 4. 1, 2, 3, 4. So now we have D prime. Same with C now. It goes 1, 2, 3, 4, 5. 1, 2, 3, 4. And that becomes C prime. Okay. B goes 1, 2, 3, 4, 5. 1, 2, 3, 4. So there's our B. And you can imagine where A is. It's going to be right here. Sorry you can't see very well. Next time I'll make my... So A prime, B prime, C prime, D prime. And you're going to go ahead and draw that rectangle. And so what this was it was a slide. Nothing was flipped or rotated. It was just a slide. So what we call that is a translation. It was translated. Okay? And now they want to know what your coordinates are. And there we go as we write them in. So A was now -1, -1. B is -1, -3. B prime, I'm sorry. C prime is -4, -3. And D prime is -4, -1. Okay, so again, you can compare them. What happens is, here, I will show you. A, B, C, and D. A, the image, or the pre-image, was 4, 3, 4, 1, 1, 1, and 1, 3. So how did we get from here to here? Notice what happened with each of these points. If we did, we translated to down 4 units. So notice that, sorry about that, or let's look at the x. We went to the left 5 units. 4 minus 5 happens to be -1. 4 minus 5 is -1. 1 minus 5 is -4. 1 minus 5. That was the left shift. Now when we went down, the y coordinates went down. So 3 minus 4. 1 minus 4 is -3. 1 minus 4 is -3. 3 minus 4 is -1. So these went -4, the y's did, and the x's went -5. So that's kind of the rule of what happened. Okay, it's alright if you didn't write this part down. What we really had to make sure you wrote was this. I'm wanting you to see the pattern though, because that's going to come up a lot. Okay, example 3, you should have this triangle made, PQR, and we are going to draw its image after a counterclockwise rotation of 90 degrees about the origin. Okay, so now we've got this triangle and actually wrote P, Q, and R and their coordinates. So what happens with the rotation is a little weird, is here it was like this, and then we're going to rotate it counterclockwise 90 degrees. So it went 90 degrees. Okay, so this triangle is going to pivot. So your R is going to be here. Okay, your Q is going to be here. And your P is going to be over here, your P prime. So P prime, anyway, it looks like this. Sorry I didn't use a straight edge. I'm hoping you guys did. I'm just realizing I'm using a lot of time of yours. So now we've got P, Q, and R. So it rotated 90 degrees that way. So our P prime, Q prime, and R prime, let's look for a pattern. There is one. It's just always a little bit different than the other two, where you just change the signs of your x or y coordinate. So P prime is now at -4, 3. Q prime is now at negative 1, 3. R prime is at negative 1, 1. So notice, do we have any pattern here when we rotate 90 degrees clockwise? Well, notice this. This was 3, 4, this is 4, 3. This is 3, 1, this is 1, 3. Don't worry about the negatives yet. 1, 1, negative 1, 1. So what happened was the x and y switched places, and the x became opposite. Does that make sense? So if this was xy, this is really kind of beyond your math level, but I just want to show you. If this is xy, what happened over here is this is negative y x. The opposite of your y value is now in the x spot, and your x is the same value, it's just in the y spot. So this is advanced math here that I'm showing you this, if you understand, and we would do this, is the arrow. Okay, in fact, a lot of math books show it this way. You did have these points, this was the pre-image, here is the image. The x and y switched places and the y became its opposite. So if it was negative, it's now positive. If it's positive, it's now negative. And that's what happens on a 90-degree rotation counterclockwise. Now for lesson 80 practice, you're going to do it on the graph paper I gave you. Letter A says to finish the examples in the lesson if you hadn't already done it. You probably should have done it already because we did it together on this video. That leaves you with three problems on practice that you need to do on graph paper. Okay, I'm showing you my first graph empty because I want you to see exactly what I want yours to look like. Look at the size. I have it at least 6 by 6. Okay, and that should cover each of your pictures. Notice I labeled. I want you guys to label this. I had to do this way more than I've ever asked you to do. So I want you to label your x-axis 1, 2, 3, 4, 5, 6, and then negative 1, 2, 3, 4, 5, 6. Your y-axis 1, 2, 3, 4, 5, 6, and you label it down. I even labeled the x-axis x and the y-axis y. And you might be wondering, why do I have to go through all that work? Why do I have to do that, Mrs. Duchio? Well, I do believe that the more you label the Cartesian coordinate plane, you're going to remember better where it's positive and where it's negative just by sheer copywork. The more you write the positives out here, positives up here, negatives down here, and negatives out here, you're going to understand and retain it better. So I want your coordinates to look like this, or your graphs to look like this. Then you go in and graph your pictures. So yes, you're going to have to do this 3 times, and you'll be okay. You'll be a better person for it and enjoy it. I just did it, and I'm okay. Okay, and it's actually fun. I'm just having you draw. All right, and I will see you at the end of the lesson, and you can come back and compare your graphs. But I don't want teeny tiny graphs. I want each graph line to be worth 1 unit. Okay, don't try and scrunch these small and change your units, please. You're going to do it this way, and you're going to love it, right? Okay. All right, I have the answers here, and I added a little bit of a bonus. I did the algebraic rule here. Okay, so what you should have is this was your pre-image, and this was your image, rotated 90 degrees. Okay, so here are your new w prime, x prime, y prime, z prime, and there are your coordinates. Now what happened was the x coordinate and the y coordinate, they switched places, and the x became the opposite. So that's the rule. If you get this, that's great if you understand that. So the x and y changed position, and the x became the opposite from here to here. So it was this, and then it became this. All right. If you don't get this, that's all right. You won't be tested on that this year. Okay, here's letter C, and here's your image, and the pre-image was rotated. We usually say rotate about the y-axis, so that means it's flipped over the y. And so now you've got your new coordinates, j prime, k prime, l prime. And what you notice here is nothing changed except the sign of the x values switched. Okay, so it was positive 1, now it's negative, positive 3, now it's negative, and so on. So the rule is x and y stayed in the same spot, but x became the opposite. Okay, so there's your answer to that one. And the last one, D, it's right here. We had some parallelograms, and these were translated to the right 6 and down 3. So here's your image, pre-image, here's your image. So we have got our new coordinates. So this part you do need to have listed. And I want you to notice that when we do 0 plus 6, negative 1 plus 6 is 5, negative 4 plus 6 is 2. So every x value added 6. Every y value went down 3. 1 minus 3 is negative 2. 1 minus, so what our rule was is the xy became x plus 6, y minus 3. So again, this is bonus information. If you get it, be very happy with yourself. If you don't, it's okay. Make sure you have this and you have the correct graphs. And I hope you enjoyed those because it was drawing and it was fun. Okay? And we will see you with one more lesson before we meet back after our break.